Hi, so let's jump right into the function introspection coding section. So the first thing we're going to do is define a function. So let's go ahead and create something. Let's say def myfunc and no comma in front, that would be illegal. So let's go ahead and create some parameters. Let's say a, b equals 1, c equals 2. So we'll create 3 positional parameters. With 2 of them will have default values. We'll take a star args. We'll take a keyword only parameter, another keyword only parameter, but this one with a default value, and another keyword only parameter with again a default value. And then we'll also take in a variable number of keyword only arguments. And we're not going to do anything with this. Actually, yeah, let's go ahead and do some stuff. Let's say I equals 10. Let's say j equals 20. And then I'm just going to do nothing. So I'm going to return none, essentially. If I don't define a return statement, it returns none. Okay, so we'll do that. And let's do a few annotations as well. So for that, I'm going to put that on different lines. And we'll annotate some of the things. So let's go ahead and annotate A. This is a mandatory, positional. This one is an optional, positional. I don't know, just some things over here. Let's maybe annotate args and extra positionals here, and provide extra keyword only here. And then maybe we'll also do the annotation for the return does nothing. Okay, since it doesn't actually do anything. All right, so now we've got this function defined. And as we've seen before, we have things like docstring and annotations. Let's actually add a docstring as well. So let's do this. Let's say this function does nothing, but does have various parameters and annotations. All right, so let's leave it at that. So there we go. So remember, now we can look at myfunc, done the doc, and we have the docstring. We can look at myfunc, done the annotations, and we have the annotations that we provided. Now, myfunc is just an object, which means objects have attributes, and we can add attributes to objects very easily. We can say myfunc, maybe short description, we'll say equals, and then we just maybe make it equal to a string. And, you know, this is a function that does nothing much. Okay. So now it's attached to myfunc, and we can actually recall that, and we can just take a look at that, and there we go, right? Myfunc's short description is this string over here. Now, in fact, we can look at all the attributes that are available on myfunc, and there's a bunch of them, and we'll look at some of them in more detail. But you'll notice that the doc attribute is there, right? The done the doc, that's the one we saw earlier. The annotations is there as well. The dunter annotations is there. And at the very end, we'll find that our short description is also in there as well. It's now another attribute of that function. But the thing is a function. So let's look at a few other ones. Let's look at done the name, right? So I can say myfunc done the name, and that returns myfunc. Well, yeah, we know that this is the name. But remember that the name of the function may not be what you put in here, right? Suppose you got code somewhere, maybe you passed your parameter in, your function in as a parameter, as an argument to a function call. Then inside the function, maybe you want to know what's the name of the function, right? Let's say we do something like this. Def, let's call it func call. And let's say we pass in f, and here we want to print f done the name, right? We want to know what is the name of that function. Well, if we do func call of myfunc, so now we pass in the function myfunc. Now remember, inside this method, it doesn't know about this myfunc name, right? It only knows about f. Now f and myfunc point to the same object. let's go ahead and do this. Let's go ahead and print ID of f, okay, while we're at it. And then here, I want to show you very quickly what the ID of my func is, right? This should be nothing new. So now let's go ahead and call this function. You can see the ID is the same, and then you can see the name, therefore, is the name of the object at that location, which is my func. All right, so that's why the dunder name can be useful. Next, let's look at the defaults and KW defaults attributes. So these two over here, this one and this one. So we can say my func dunder defaults, and there we have 1 and 2. Remember what our defaults were? This was the function, right? We had B was 1 and C was 2 as the defaults. So that's what we have here. And then my func, remember we had 2 keyword only arguments with defaults. We had 3 keyword only arguments, but 2 of them only with defaults. So we can look at the KW defaults property, and it's a dictionary that gives us the key value pairs, where the key is the keyword name, the parameter name, and the value is the default that was assigned to it. All right, so that's an easy way of returning defaults. But you'll notice that you only have 2 values in this tuple over here. So the number of positionals was 3, but we only got a tuple containing 2 values because only 2 of them had default values. Now remember that once you start defining a default value or assigning default values to a parameter, every parameter after that in the positionals has to have a default value as well. So be careful with that, or remember that, because this means that when you want to try and match up your list of parameters, of positional parameters, with your default values, you have to work your way from right to left. So 2 goes into C, 1 is for B, and then A has nothing, right? So just keep that in mind. You don't have the same problem with the keyword only because it's a dictionary where the keys are the parameter names. Next, let's look at my func. Let's look at the code attribute. Now the code attribute is itself an object, right? It's a code object. And so we can look at what that object actually has. We can look at dir of code. And that gives us a bunch of things, right? It's got these like dir, well, it's got the dir property because, well, that's what gets called when we call this function, right? But it has some other interesting ones that we're going to look at, like arg count and name, right? And val names. So let's take a look at that. So let's say we have my func, dunder code, dunder, and then co name, for example. Well, that just gives us the name of the function. So we already know how to do that, right? We can just use the dunder name on my func directly. But you also have this, my func, code, val names, right? And that gives you the name of the variables and some extra stuff. So here we have the variables, the positionals, A, B, and C. Here we have the keyword only arguments. Then we have this args and quags, right? So this is still all the parameters that we had. And then we have this ij. What's ij? Well, remember when we defined this thing, I put in these 2 kind of dummy variables, right? We didn't do anything with them, but we declared them. That means that in the scope of my func, we have not only all the parameter names, right? These are variables in the scope of my func, but we also have ij. And that's what variable names does. It actually also includes any local variables that you've declared inside the function. So that can be pretty handy to figure out what's inside my function, right? What's going on inside. Another one that you have is my func code. And I want to show you this one, not because it's particularly useful by itself, but because there's a catch. You might think that, oh, arg count, right? This one over here is going to tell me how many arguments I have in my function definition. And here it says 3. Well, that's a problem because what about, here's A and B and C, there's 3. What about star args and KW1, KW2, KW3 and star quags, right? It doesn't show up there. So it's only showing us the positional arguments, right? So again, just keep that in mind. It only shows us the positional arguments. But that can be useful because if we look at this default over here, right? And we want to know the defaults, right? We want to know the variable and the default value. Well, we can pick up the defaults from dunder defaults. Then we can pick up all the variable names that start with the positionals using coval names. And then we can pick out of that, we can pick out which ones are the actual positional arguments. It's the first three. That's what our count is giving us. It's the first three here. Okay? All right. Now, you can certainly work that way, but much better, or at least much easier, is to use the inspect module. So we can just import the inspect module, and I'm actually going to do a little bit more. I'm going to say from inspect, import is function, is method, and is routine. So I'm going to use those three functions just to show you some stuff. So we can use is function to look if something is a function. Let's go ahead and declare just a variable. Let's make it an integer. And we can ask, is function a? Now, of course, the answer is false. It's not a function. But if we pass in my func, then we get that it's true. Now we have is method. Let's just pass in my func. I'm not going to use a again. We know that that's not a method either. And neither is my func. So remember the distinction that we make between functions and methods that was discussed in the lecture in the previous video. I tend to use the words a little loosely, but methods are things that are bound to a class or to an object or something like that, right? A function is more of a standalone thing. A lambda expression generates a function, right? Def will generate a function, but depending on how you use it, it will be a method. So methods and functions are both callables, right? You can call them. So they look the same, they kind of behave the same, but there are some differences. There are some, pretty major differences actually between the two. Because when you have a method, it's bound to an object or a class, so it's actually expecting to receive the class or the object as a parameter when it's being called. So it's a little bit different. So let's go ahead and look at that. Let's go ahead and create a class. Let's say my class. And let's create a function here. Let's just call it def. Now this is going to be an instance function, so it expects to receive the instance as a parameter. That's what we do here. And we'll see this in detail in the object-oriented section. I'm not going to do anything with that. I'm just going to return that. And I want to show you that we can call is function my class.f. And the answer is true. It's a function because it is not bound to my class. On the other hand, if we do my object equals my class instance, so now we've just created a new instance of my class, my object points to that, then if we look at is function of my object .f, we get that it's false. It is not a function. Why? Because it's actually a method. Let's actually call it f. All right, so there we go. So that's true. All right, so keep in mind that there's a difference between function and method. Now, if you're not concerned about the difference, you can just ask, is it a routine? So you can say, is my object.f a routine? The answer is true. Is a routine of my class.f? Then it's true as well, because they're both the same. Because it's either a function or a method, and it's a function in one case, method in the other case. It doesn't matter. It's still a routine, right? A routine is it either of those? Next thing we can look at in the inspect module is how to get the source code for the function back. So remember what our source code was here, right? Essentially, we had this docstring annotation, and then we had the those two dummy variables. And we could add some other stuff in here. Maybe I'll say a equals I plus j, return a. I just want to add a few more lines of code to this function. Now let's go back here and let's look at the inspect. So inspect, we have the get source function in the inspect module, and we can pass in our function myfunc. And there we go. Here's the code, right? This is the entire code. We have the function header with the annotations. You have the docstring over here. You've got, your new lines. You've got your line of code, I equals 10, j equals 20. So if you want, we can make it look a little nicer by just putting a print in front. Let's actually print it out. And here we go, right? We have our function right there. So that might come in handy, especially if you're trying to create, let's say, classes or functions, or something that maybe documents code, right? Very handy to be able to pull the code back out of the Python code, right? You can call any function. Now, of course, if I have something like this, f equals myfunc, remember, it's no different, right? F still points to the same object. You still get the same thing. Now, we can also look at getModule. That's another thing in the inspect function, in the inspect module. And we want to know where something is defined, potentially. So let's look at myfunc first. Well, it tells us that myfunc is defined in the module main. Well, that's where we're at, right? We're inside this module main when we're inside this notebook. But you can also use that for looking at built-in things. We can look at getModule of the print function, let's say. Right? And it tells us it's in the module called built-ins. So there's a module called built-ins in Python. This is where print lives. And it's a built-in module, right? If we import math and then we inspect and get module on math dot, let's say, sign, the sign function, I have to spell correctly, right? Or type correctly. Then we get that it tells us that math.sign is in the math module and it's built in. Now again, it's useful for the example that you've got a function, you don't know where it is, so you can find out its name, you can find out its code, you can find out where it was defined, right? Kind of useful stuff. You can find out about its parameters, about its annotations, its docstrings. So there's a lot going on with introspection that you can do. Let's look at something else. Let's go back to this function here, and let me go ahead and type in maybe a comment, and I'm going to say to do fix this function, right? So here I've got a comment that immediately precedes my function. Now if I've got some code over here, let's say I've got dummy code, maybe I equals 100, okay, and I execute that. So I've got some comments, right, just as we put normally in our code. I've got a comment, some code, then I'm documenting something. I want to document something about this function. Typically, I'll put a comment right before the function. And very often, I'll use a to-do. This way, I can search for to-do in my code and find out what do I need to do still, as a reminder. A lot of IDEs will actually pick up on that and will collect all that information for you and present it in a view where you can then go and look at a list, essentially, of to-dos. And you can click on them and go directly to that piece of code. So that's really handy. And one way that you can get that is by looking at the comment that's kind of attached, right? This comment is kind of attached to this function. That's how we look at it as we're coding. And so Python can actually do that for us as well. And we can look at inspect.getComments of myfunc. And it will return that comment right here, to do fix this function. Now, if I have multiple lines, right, currently does nothing but should do blah, 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 okay? So let's say I've got 2 lines of comments. If we rerun this, well, we get both lines, right? To do fix this, \n, right, for the new line, and then the next line of the comment. So again, pretty handy if you're writing some piece of code and you want to pick up, let's say, all the comments that are associated with a function. That's not the same as a docstring, right? myfunc doc is different. It's that document string that we have inside the function. This is more something of where we're writing a comment outside of the function, but we want it associated with the function. As long as you keep it right before the function definition itself, it will get, picked up and attached. Next, let's look at the signature. How can we introspect the signature of a function? We've already seen some of it, right? Using the code with co-count and co-val names and defaults and kw defaults, but it takes a little bit of work to, kind of get things that we want out of all that. So the inspect module really cleans that up for us quite a bit as well. And we're going to look at, from the inspect module, we're going to look at the signature. And we're going to take a look at signature myfunc, right? Let's take a look at that. You'll notice that it returns an object, right? So this is an object of type signature. So it has properties as well, right? It has attributes. So we can look at the attributes by using dir signature, my func, right? So we're just going to do that. And it has a bunch of stuff, right? In particular, it has things like parameters, which is what we're going to look at in particular in this video. So let's take a look at the parameters. And you'll notice, by the way, it also has return annotation, but then we know how to pick that up from the annotations dictionary. But this just basically gives it to you along. Let's just take a quick look. My func annotations, right? We've seen that one before, right? So we have return does nothing, but if we do my func inspect dot signature of my func dot return annotation, need to put in the things in the right place. I'll get it eventually. All right, does nothing, okay? It just returns that one here, but obviously we can pick it up from here as well. Again, it just shows you that inspect doesn't really do a whole lot more than what you can do yourself by using introspection directly on the function. It just packages it up nicely for us. It's much easier to use. So now let's look at the parameters. That's the one really that I wanted to look at. So I'm going to create a variable sig so I don't have to call inspect.signature every time. And I'm going to assign it the signature object that we get back when we call the signature function. Okay? So here we have sig, and again, sig is just that signature object that we saw earlier. But we can look at the parameters of that. So let's look at sig.parameters. And that again is something else. And essentially, this is a dictionary. So we can go ahead and say for key, comma, value in sig.parameters print k, comma, v. And parameters.items, sorry. So we're just going to iterate through those things. And so you can see that we get A, right, B, C, args, KW 1, 2, and 3, and quang. So we get all our parameters, right, that we have in the function, and then something that gets printed after that. So let's go ahead and look at what the type is, because, right, it's not just a string. It's actually a type. It's the parameter class, essentially. These are instances of the parameter class. So what I'm going to do is I'm going to iterate through that, but I'm going to say, so V is a parameter object, right? So if we have a parameter object, it has properties. So let's go ahead and print dir of V. Now it's going to print it out many times, but let's see. So we have some things like keyword only, positional only. So it's got a bunch of stuff, right? Default, empty, kind, name, right? Annotation. There's a bunch of properties that this parameter type has. So let's go ahead and actually use that. And one of the things that it has, by the way, is a name. So let's go ahead and do all that. So we're going to print name. And let's call it v.name. Actually, you know what? Let's do this. So we're going to print the key first. The key is k. Then for name, we're going to take param.name. So we're going to look at the name property. Then we're going to print out the default. And that's going to be param.default, right? Then we're also going to look at the annotation. And then we're also going to look lastly at the kind. And we've seen that in the lecture. And then lastly, I'm going to print just, a bunch of lines just to differentiate each, key and value as it comes through this loop. All right. So here we go. So key A, name A. So you can see that the parameter name and the key are actually the same thing. So technically, we don't need, if we're iterating through the parameters, we can recover the name by using param.name. We don't need the key. So I'm going to take that out. And instead of iterating the items, I'm going to iterate just the values. So we'll clean that up a little bit, except of course we don't have a key. So let's remove that and let's rerun that. Okay, so cleaned up a little bit. So here we have the name is A. So this is the parameter A. It has a default. Well, it doesn't have a default. So it's got this empty, right, default. The annotation is, and I forgot to put a colon to differentiate where alt text was and that value was. So the annotation is mandatory positional, right? That was our annotation. And the kind is positional or keyword. B was the same thing, except it had a default. It also had an annotation, and its kind was positional or keyword. C, same thing, right? Then we have args. The kind is var positional, right? It was a variable number of positionals. Then we have our keyword arguments, our keyword only arguments, kw1, kw2. You can see their kind is keyword only. Again, if you have defaults, you have the default. If you don't have annotations, you don't have them. If you have them, they're there, right? All that works out the way we would expect it. And finally, we have quarks with var keyword, which was a variable number of keyword only arguments. So the one thing I also wanted to mention, we talked about that in the lecture, but there is an additional kind that we can't actually define, but that does exist, which is positional only. So let's take a look at that. Let's look at help on div mod. Remember that function when we were working with divs and mods? And you'll notice in the documentation that we have x comma y, so it takes in two parameters, and then this slash over here. And I know we've seen this documentation before, and I never discussed that because I wanted to leave that to this discussion here where it will now make more sense. But what this means is that the preceding parameters are positional only. So I can call div mod by saying, let's say 2, 3, right? Which gives us 0 and 2, right? 2 div 3 is 0, 2 mod 3 is 2. Let's do, if you want, something that maybe makes more sense. 4, right? We have 1 and 1. What you cannot do is do this. You cannot say x equals 4 and y equals 3, right? These are the parameter names here, x and y. So if you try and say div mod of that, it tells you, nope, div mod takes no keyword arguments. That's because the arguments of div mod, 4 and x and y, are positional only. In fact, let's use the inspect module to check that out. So let's say inspect dot signature, right? We have to look at the signature of div mod and then the parameters, right? And then we have to iterate through that. So for param in that dot values, okay? Sorry, don't want to run it quite yet. And we want to print param dot, we'll just print param dot kind, okay, in this case. And here we go, we have positional only. So these are the positional only types of parameters I discussed in the lecture. We can't create those, right? We can't use a slash in our function definitions. Python, on the other hand, can, right? But we can't. All right, so thanks for watching, and I'll see you in the next video.